Hello. Can you hear me?
I can hear you.
Okay, thank you. Last class, we did critical path method with a single activity time is made. Today, we will cover 3 activity time estimate because the activity time sometimes we can finish early, sometimes on time, sometimes finish late. So there are 3 activity times: early time, on time, and late time. So times are uncertain. So using 3 activity times, we can get probability information about that project. Example, there are 3 activity times. A is optimistic time, kind of finish early, and M is most likely time, on time, and then pessimistic time, B. So using this formula, expected time equals A plus 4M plus B divided by 6. Because coefficient of this one, 1, 4, 1, so 1 plus 1 equals 6, so divided by 6. This is kind of weighted average. So using 3 activity times, A and B, we can get expected time. It's like, I will show how we can calculate. So this one, expected time for A, activity A equals, A is 10 plus 4 times 22. This is 4 plus B28. B28 divided by 6 equals 21. This one. So using this formula, A plus 4B, 4M plus B divided by 6, that is expected time. So after calculate expected time, it looks like a single activity time. So using designation, immediate predecessor, and expected time, we can draw a network. I think you can draw a network using immediate predecessor. Then activity time. This one is actually expected time. So 21, 4, 2, 5, 2, 8, 7 from this chart. Then for a single activity time, we did determine early start and finish time and late start and finish time, but this time we don't need. Then critical path. Last time I give you how to find a critical value, critical path. So there are 3 possible passes. This one, this path, and last this path. So first possible path is A, B, D, E, G, this path. And then next one is this path. So A, B, D, F, G. And then last one, this path, A, C, F, G. So this one, 21 plus 4 plus 2, 5 plus 2. So this is 34. The next one, this one, 21 plus 4 plus 2 plus 8 plus and 2. So that is 37. And next path, ACFG equals 21 plus 7 plus 8 plus 2 equals 38. So among 3 possible passes, this one is longest. So ACFG is critical path and duration is 38. Okay, so far, question? Okay, good. Because the activity times are not certain, uncertain, so it can finish sometimes early, sometimes late. So it is normal distribution. So 38, that is kind of average time, most likely time. Then it can finish early, like 35, maybe late like this. So question can be like this. The probability of completing the project in 35 weeks. In 35 weeks. So in this distribution, the area is this side. In 35. So finding this area using formula, this one, z equals d minus te. D is desired completion time, and then te is expected completion time. So this one is asking 35 desired completion time, and this one is expected time 38, and divided by square root of sum of standard deviation squared. This one is variance on critical path. On critical path. This is important on critical path. Anyway, we need standard deviation or variance sigma square. Using this formula, variance equals B minus A, pessimistic time minus optimistic time divided by 6 and square. So we can get variance for each activity. This one. So variance activity A equals B minus 28 minus A 10 divided by 6 and square equals 28 minus 10, 18 divided by 6 square equals 30 square. So it is 9. So using this formula, B minus A divided by 6 and square, we can get variance. And then for G score, we need square root of sum of variance on critical path only. So add only on critical path. Critical path is ACFG. So we need variances on critical path A, C, F, G. So 9, 2.78, 0.11, and 0. So the probability of completing the project in 35, desired completion time, kind of asking time, 35 minus expected completion time, the duration of critical path, 38, divided by square root of sum of variances on critical path. So variances on critical path is 9 plus 2.78 plus 0.11 plus 0 equals negative 3 divided by square root of 11.89 equals negative 3 divided by 3.45. So result is negative 0.869. So round up to decimal point. Because we will use chart, then we need 2 decimal points. So negative 0.087. This is z-score. Z-score is like this. Z-score means on normal distribution, mean is 38, and then we need boundary of 35. And then z-score for this mean is 0. And then this left side is negative, and then right side is positive. On this boundary, z-score is this one, negative 0.87. So using this z-score, we can find area from normal distribution chart. So try to find negative 0.87, negative 0.87. Negative 0.87 is not there, not exact 0.87, but between negative 0.90 and negative 0.85. And then negative 0.87 is between negative 0.90, negative 0.85, then 0.86, this one is closer to negative 0.85. So take negative 0.85 and take this area. So this area is left side of that boundary. So drawing again. $38 here, 35 here. So this area is 0.19766. So this area is this one. And then the probability of completing in 35 is 19.766%. This is the answer. Okay, question so far? Okay. We can make another question. The probability of completing the project longer than 40 weeks, longer than 40 weeks. $38 here, and 40 is right side of that 38. And then it says more than or longer than. So this area. So we need z-score on 40 boundary here. So using the same formula, z equals desired asking time d 40 minus expected completion time 38, and then the same variance on critical path 9 plus 2.78 plus 0.11 plus 0 and square root. So 40 minus 38 is 2 divided by square root of 11.89 equals 2 divided by 3.45 equals 0.58. So find 0.58 on the chart. 0.58 is not there, but between 0.58 is closer to 0.6. So area is 0.725, 0.72575, but the answer is this one, 1 minus 0.72575 equals 0.27425, because when you answer, be careful. When it was 38 and then 40, the chart gives this area. This is from the boundary left side. So in or less than. But we need this side. Right side of that boundary. So total is 1. So 1 minus left side equals like right side. So longer than or more than 40 is 27.425%. So if question asks in, then find that area from the chart. Let me show you the chart. On the top of the chart, the given area associated with the z-score is left side. So this chart gives us left side from that boundary. So if we need right side, because it asks longer than, greater than, more than, right side, so we need this another calculation. So 1 minus 0.72575 left side area equals right side area. So answer is 27.425%. Question? Okay, next slide. This one is not in your lecture notes, but just show you what it is. Time cost model. Earlier, types of critical path method. if we have time and cost information, then we can use time cost models or PERT, P-E-R-T. So using time and cost model, find the least cost project time. So here, if there are 4 activities and then immediate predecessor, normal time, normally using normal capacity, then completion time, normal time. If add employee or machine, then we can crash shorter time. Then how much normal cost is the normal time, normal cost. To finish normal time, the cost is normal cost. To shorten the time, we need additional cost like this, like add employee, worker, machine, and so on. So using normal time, normal cost, crash time, crash cost. First draw network, and then normal time, normal cost, crash cost, crash time, and crash cost. Okay, here, normally, this one can finish 10 days. Then if we use more machine or more employee, then how can we shorten project time? Adding activity D, increasing the capacity, then cost increase, time crash by 1 day, and then increase another in D, then $2 more, and 1 day crash and shorter. So using this crashing possible activities, and then add dollars and so on. So continue that crashing until this time. Even add capacity or more machine, cost increase, but time not crash it, then stop there. So this is a time cost model or PERT. Just to show you, this is PERT. So using this, we can find the possible completion time. And then in real world, we may use computer software. There are many. And then in academic area, we mostly we use Microsoft project software. So it looks like this. So give information, activity, duration, and start time, finish time. Then this one automatically produce a Gantt chart like this, and then automatically draw network diagram, and then show which path is critical path in red like this, and so on. Okay, practice problem. Do you have any questions so far? Okay, good. Practice problem. This practice problem, as you know, on Moodle. Okay. On given information about the project, there are blanks like this. Then you need to fill out here and here. So this is expected time for activity D. So using expected time D equals A plus 4 times B plus M B. This is M, most likely time, divided by 6, equals A is 3 plus 4 times 4 plus 5 divided by 6 equals 8, 24. So that is 4. So here four, and then this one is variance for activity D equals B minus A divided by 6 square equals, so 5 minus 3 divided by 6 square equals 2, 6 square equals 1/3 square equals 0.111. And then let me check if it is right. Yes, right. Then we need to figure out which one is critical path. So there are three possible paths here: A, B, E, G. By the way, here 0.111. And next possible path is this one: A, B, D, F, G. Oops, it's gone. G. So again, A, B, E, G. Next one is this one: A, B, D, F, G. And this one: A, C, F, G. So equals A, B, E, G. It was 4.111. A, right here, 3, 8, 6, 4, 3, 2, 4. So AB, 8 plus 3 plus 4. And this one, 3 plus 8 plus 4 plus 2 plus 4 equals 3 plus 6 plus 2 plus 4 equals 18. Okay. 21 equals 18. So 21 is longest. So critical path is this one. So this one is 3 activity time estimate. And then question is longer than 24. So Z score equals desired completion time is 24, this one, minus expected time 21, divided by square root. Square root of variances on critical path. Critical path is A, B, D, F, G. So A variance 0.111 plus B 1 plus D 0.111 plus F another 0.111 plus 0.444 equals 3 divided by square root 1.777 equals 2.25. So from the chart, find it was 2.25. This moment. Yeah, 2.25. So find the 2.25. 2.25 here. Fortunately, we can find the exact one. 2.25, and the area is 0.98778. 0.98778. So answer is 1 minus 0.98778 equals 0.01222. Because this one asks right side greater than, more than, or longer than. Let's select. Expected time is 21, and desired time is 24. Then asking longer than, so this area. So using this z-score, the given area by the chart is left side. So right side is 1 minus left side equals right side. So answer is 1.222%. Question?
Is this on Moodle? Like on the page?
Which one?
Like this solution, is it on Moodle?
Yes, it's already on Moodle.
Okay.
And then you have assignment. And then the question, if it is on Moodle, the practice problem answer is here on Moodle. And you have assignment number 4. Due is coming Sunday night. And then I will go over similar question. I will make it available. Now you can see this previous assignment number 4. I will go over this one. So if you need to find this file on Moodle, and then okay, I will give you 5 minutes. Look at, then 5 minutes is too short to try, but anyway, read and then think about it. How can you solve this problem? So I will be back in 5 minutes. So I will be back 4:50. Now it's 4:44. So look at it, okay? Okay, I'm back. When you do the assignment, almost the same, similar. First step is fill the blank here and here. So expected time. Expected time for E here. So expected time for E equals A 9 plus 4 times M 12 15B divided by 6. Assignment 3. Some students didn't hand in. I will extend due by tomorrow night. So if you didn't hand in the assignment 3 yet, please hand in by tomorrow night. After I give answer, upload on answer on Moodle, there is no chance to make it up. So if you didn't hand in the assignment 3, please do and hand in by tomorrow night. And then I received an email from a student. When I go in a lecture, understand, but later when the student do the assignment, don't know, don't understand. You need practice. So when I do go over a practice problem, do together, okay? And then this one also, when I do like this, then do it together, okay? Then if you don't understand or don't know, then email me and then set up a meeting with me. Actually a Zoom meeting individually. Then ask me, okay? But as early as you can do. Like tonight is not due, but you start today, and then asking me how can I do like that? Then there is no time to help you. So at least 1 or 2 days earlier. Try, and then if you don't understand, then if you need my help, then ask me at least 1 or 2 days earlier. Okay. So do it together. Okay. Then if you have a question, then ask me right away, and then I will explain more. Okay. So equals. Answer is 72 divided by 6 equals 12. And then next one is this one. Variance for E equals B minus A. So 15 minus 9 divided by 6 and square equals 6 over 6 square equals 1. Then we need a z-score because this one asks 44, longer than 44. So z-score, we need to determine which one is the critical path. So draw a network. So using activity and immediate predecessor, draw a network diagram. A and B, they don't have immediate predecessor, so A and B are starting point. A and B. A expected time is 6. B is 7. And then C from A and 11. And D and E from B. D 10. Oh, C is 11. And D is 10. E is 12. Then F from C and D. F is 17. C and D. I'm sorry. $17. And then G from E. and H from F and G is 18. So there are three possible passes here, here, and here. So A, C, F, H. The next one here, B, D, F, and H. And last one, this path, B, E, G, H. So 6, 11, 6 plus 11 plus 17 plus 9. That is now 43. And this one, 7, 10, 17. 17 plus 9 equals the same, 43. And this one is 7 plus 12 plus 18 plus 9 equals 46. So this one is longest and critical path is this one. BEGH, BEGH. Then we need Z-score. Desired completion time is 44 minus expected time 46 divided by square root of variance is on critical path B 0.444 plus E, it was 1, and G 0.111 plus H 0.444 equals negative 2 divided by square root of 1.999 equals negative 2, 1, square root of 1.999 is now 1.41. Okay, arc, so 1386 equals negative 1.415, so approximately negative 1.4. So from the chart, normal distribution chart, find negative 1.4. So 1.4 is, where is it? Not here. Oh, 1.4 here. So area is 0.08076. This one. Normal distribution, 46 here, and 44 here. And then asking area is longer than for this side. But from the chart that area is left side is 0.08076. So right side area, the asking is 1 minus left side 0.076, so equals 0.91924. So answer is 91.924%. Is there any question? Do you have any question?
Not on my end.
It's okay, okay. If you don't have a question, that's all. By the way, this file, the previous assignment number 4 question is on Moodle, but answer is not on Moodle. This is answer. So when you do the assignment, answer looks like this. Okay. Okay, that's all. And then if you don't have a question, then see you Wednesday. Is David Jedder there? Is David there?
Yes, I'm right here.
Okay, if we have a question, then remain. Otherwise, now see you Wednesday.
How you doing, sir?
Yeah, good. Okay.
Have a good night.
Good night.
So yeah, let me just pull up my
Okay, just a moment.